Welcome everyone to another low-level Linux kernel regression, bug fixing and stuff live stream here on our low-level YouTube channel. Who doesn't know it? The only constant is change and regressions, and you want to release a new version of your outstanding operating system and latest compiler infrastructure mega project breaks compiling the Linux kernel with LLVM Clang LTO. The issue is, as you can see in the log file, that LD, so that only occurs with LTO, link time optimization, but who wouldn't want that for another % of performance improvement? And it only happens for the x32 ABI. x32 ABI. Here's some VSO, vclock, get time. I was like, yeah, just last week, fixing HPPA risk, Hewlett-Packard precision architecture risk, VDSO every week, the same similar stuff on another architecture. Data is too short, I believe. So this only occurs for the x32, which is a relatively unused, higher performance potentially, but less address space, 32-bit pointer running in AMD 64 mode. I tested, we could simply disable that. There is a config ABI x32 option, but I fall for this. So that would be the short solution, right? Other people like Red Hat and SUSE probably like, yeah, x32 deprecated, nobody uses this higher performance mode. But we are not like that, right? We would want to fix it somewhat for real, so we better analyze what's going on here. I looked into that already some days ago, and I thought I found somewhere they changed the default to generate PIC, precision independent code. But I googled for 5 minutes. I didn't, it was like, here, it's like a recurring theme. When you work on something, finish it, because 3 days later, which LLVM Clang bug did I look into? So analyzing this as usual is a little bit annoying, because recurring theme here, right? I'm not a fan of hiding build stuff, because like if you just build it like this, you have no log of, it's like, yeah, what? It's like how to debug this recurring theme. This is between some news sites, hey, it looks so clean now. It's like, yeah, it looks so clean now, but like VDSO building stuff here. The bug might already be in this. So how do we run this, right? We run this with -v, but this 2023, this is then 2 verbose. It's like, yeah, make F. It's like you had one job. I wanted to see what's run and not entering each directory. Thank you very much. This is why I have saved this here to the log to better see that. So that does apparently LDD, the LVM. I should, by the way, check that. LLD should be, probably come straight from, yeah, LLD, of course, but better to check that and be sorry. So that complains that that data is too short. So ELF section, I probably should more dedicated videos of the executable and link format, ELF, and other such details. So hash style both. It's probably whatever old-fashioned and GNU probably. Build ID SHA-1, frame header, symbolic, no execute stick. ELF, ELF, 32 x86, max page size and stuff. So that should do from, the question is where is the, so it works on that. And I probably that is already like invalid or whatever. Let's maybe object dump that. Oh, there's something in though. VDSO get time of day. So there is, so it's not like freaking empty. By the way, if you wonder what those VDSOs are, these are virtual dynamic shared objects. Let's VDSO Linux or whatever. Virtual dynamic, I was spot on. Those are virtual because normally you have that .so shared objects for libraries like libset, and those virtual dynamic shared objects are maybe dynamic from dynamically created, so whatever, but virtual coming from, they are not files in your file system, so usually all the SOs are of course Unix files, but this virtual dynamic come dynamically virtually from the kernel mapped into the address space, so they are then not in the file system, but supplied like virtually supplied in virtual memory, supplied by the Linux kernel, depending on the kernel version. So they are optimized, like virtual dynamic optimized stuff of high performance, get time of day, and so what they do is they map other pages with data, sometimes at times even dynamic runtime data. So for example, the time, right? So the time structure of the Linux kernel is then also mapped, and so because they could change, the user space is not directly accessing proprietary kernel specific data structures, but those functions are built for that Linux kernel, for those structures, for that configuration, for example, for get time of day and other random or whatever. Clock get time, what else do we have here? Clock get tree. That's already everything we have here. So GNU properties. So what's going on here? Node GNU property. So it's not empty. So that's the x80. So why does this not freaking work? So this detective work is usually time consuming to understand what exactly broke, but I thought I saw somewhere 3 days ago, so what do we, that, because the question is why do I don't see this now, but also recurring pro tip, right, diagnostics. I can't, this was like just with LVM2 the other day, or like basically everything, right? Clear diagnostics are gold worth, right? Instead of wasting an hour of detective work here of analyzing what precisely is going on. Ah, yes, by the way, oh wait, is this here? No, this is grabbing, no, because adjust relocation is not supported. That is part of the grab none LVM NM. So what? So LD says data too short. What does this? So what does it do? It does LDD output to debug shared. I'm not really sure why they call this debug though, but whatever, I guess. So they have here shell check undefined with LVM NM that if x86 read elf grab none, then dynamic recursion are not supported. Okay, let's maybe run this independently. So this would be a read elf on this. By the way, this is not generated, right? Maybe this doesn't even run yet. So it's pointless to run that because it's, by the way, we have here multiple, right? Or maybe the VDSO node, wait a second, what was the precise? Maybe only the VDSO node file here is too short, not the others. Let's see. Nah, copy and pasting from Tmax. Maybe I should one day Google if this can be improved because it sucks a little bit for. Yeah. So but no, all of those node GNU property data is too short from. So this is of course, nah. The question is, did the real error occur? No exec stack, SO name, next page size. Not GNU property read. Oh yeah, disassemble, right? So that was the clock get time x32. What is in this? This node is probably being disassembled. How is this too short? Not GNU property. What do we get for the other ABIs? Like this one. We probably this is probably misleading. Because it's not x86 assembly. So from this we do get, so this is why different tools, different output. Displaying nodes found, owner GNU, data size 10, anti-GNU property type 0, invalid name, size, found at offset 0. So this is indeed errors out here with that. So how many do we have? We have get time, node, and we get CPU. Did it? LLD. We link in we get CPU, and that's might we get CPU. But this is also invalid. Yeah, so this extremely sucks. This is why if you write an operating system or work on low-level stuff, you slowly but steadily become an expert in, you gather knowledge of everything you never wanted to know. Warning, notice in name size found at 0, type 5, name size. So yeah, that's of course super cool. What we probably could do is delete those files and have them rebuilt and with verbose and make, save that to log and observe if we get any additional warnings already when those files are built. ADSO object copy. What the heck? Why does it? How is this straight a object copy from? What do they do here? I would have thought they... So they just object copy? What the heck? I thought they built this with... How does this even work? This should be 32-bit pointers. How can they just object copy that? I would have expected they run GCC with x32. I'm shocked. How does it even work? Maybe we should analyze how this is even supposed to work. I'm surprised. What do they have in the make file here? x32 files to link into the kernel. Which images? By the way, do we have VDSO32 enabled? x32 processes use VDSO to access 64-bit kernel data, build VDSO image. Compile x32 as 64-bit, convert object files to x32. build x32 VDSO images. So that it can reach. What the heck? Build x32 VDSO image? What are they even freaking doing here? Compile x32 VDSO 64-bit. Convert object files to x32. Build x32 VDSO with x32 objects which contain 64-bit codes, so that it can reach 64-bit address space with 64-bit pointers. That sounds like an extremely grave hack. I mean, wow. Okay, I didn't think about this, but so yeah, you run with 32-bit pointers, but then your kernel address space is. I mean, sure, you can still. I mean, it's in 64-bit mode proper, so you can have 64-bit pointers. Like, wow. How did this even? That's even like, my mind is blown. That doesn't even happen often. This is a gross hack. Like, this is one of the grossest hacks I've ever seen. I shouldn't say that. I've seen gross hacks. Wow. Okay, previously it worked though. We didn't have such an issue here. I should. So the thing is, I had found a bug entry for something of that sort. Maybe I should probably spend. So what you could do is you could bisect this, right? You could bisect LLVM Clang and like continuously rebuild that until you find what LLVM Clang change broke that. I found something matching some data, which probably I should spend some more minutes because apparently someone had figured that out already. But I mean, obviously it's not fixed. So this I'm building. Actually, we can commit this already for all the other fans of T2 playing along at home. So this is the latest stable update just out now. That I hope they fixed it, but they didn't. So you get that to play along home already. Let me quickly pause this live stream and do some Googling, because you don't need to watch me Google. And let me try to find this LLVM bug. I mean, the only other thing, so that's this one, and relocatable, because someone had somewhere reported that is due to a change in defaults of defaulting to position independent code. And I mean, maybe we quickly test that. Then a temporary workaround of potentially hopefully working code is to build this as no pick potentially. That apparently was previously the default and was working. Because someone reported that the real issue, all right, I think someone probably debugged it somewhere, which I don't find right now, that they tracked it down to some code line in the LLVM x64 emitter of some conditions not handled there, which I mean obviously is what it looked like. And welcome everyone. Ian, I forgot I asked last time. I forgot I asked last time. Ian, right? So I checked already. I can't, like, I have not limited URLs, right? I also hate this. I don't know what's up with YouTube. You can paste it probably if you change the first, like, edit the URL in your browser and change the first slash to space so that you have domain space remaining URL thing. I mean, it is supported in LLVM Clang, right? It's just some support. Yes, that's not Comic Sans. It's Comic Code, of course, a professional, commercially licensed font for to make me debugging bugs and regressions more comically happy. So it is supported, just not some bits and pieces of it. But yeah, URL welcome. We might be able. So I deleted those here, right? I wonder which. Anyway, it doesn't. I mean, it is the x32. Yeah, I mean, it makes sense. Only, like, if they built this twice, only the x32 variant exhibits this. Before we further Google, we can also. By the way, do we have a proper Clang manual? Nah. Nah, why should we have? Nah. It's mostly GCC anyway. IS64, thank you very much. Code generation. Is this not? Here is the following options are combined in the following scheme. Something of that might, like, according to my 3 days ago research, which now I can't find anymore, this might work around it. Let's see what happens. Arch. I mean, we could theoretically LVM. Is it? Probably should be an LV. I guess it should be an LVM. Do they have Baxilla? Probably they don't have Baxilla, or something similar to Baxilla. Ah, yeah, the problem is this shit is so read-only archive GitHub to use GitHub to submit LVM bugs. Oh, okay. That's welcome because it probably searches better. Let's see if we can find sec faults. Constraint, unknown, selection tag builder. Oh, here maybe? Crop debug string 2023, but it's freaking old. Mod deck that is open since no one assigned, none yet. LVM object copy produces crop debug string for ELF. Oh, that's reassuring. You had me at. Okay, but that should also not be as like, yeah, it's not really what we, yeah. I wonder where I freaking found that the other day. Maybe kernel. Probably should search my browser history. Like 2023, Google so bad you find it probably faster with your browser history. Please use whatever. Yeah. Okay, fine. You had me at search, doesn't work anymore. There was this. This was entry, right? Entry VDSO. Oops. X32. Ah, here we have FPIC actually. But we need X32. Where do we have X32 options? Object copy. So which of those failed anyway? Alright, we probably Why do they even call this debug? Is this debug or is it some other trampoline thing? S flags. Like, who doesn't love reading this overly complex? I mean, I need to give credit, at least it's somewhat readable. What was even the... where is even the freaking right thing to hook into? We need, so this stuff is built multiple times, so what we really, probably really need. So this is build Clang 32. It's M64, code model kernel. Yeah, you see here is no pick. But we need X32. Where do they build X32 image with X32 objects which contain 64-bit code so that it can reach? Or is that, this is so bizarre. Do they only compile it once? Maybe this is failing because it's out of spec of object copying. Yeah, let me try to find this other object copy. Series disabled, but this does not appear to be upstream. So that was already 2023. So there was some known issue. This issue disables x86, x32 ABI with LVM object copy, which has two outstanding issues. 1 year later, more than 1 year later. The first patch is moves the X back to kconfig proper. Conclusion was that check was still needed because the issue ever introduction of IBT. The second patch builds on the first universal disabling config when so that it's visible. Okay, so that is, I mean, so there was something, but why did it work previously? So this obviously, I guess, was not committed. Do we have comments here? So this was previously already an issue. I wonder what I found then the other day. It was like, yeah, over like 1.5 years later, bugs are still not properly solved. Okay, let's maybe check, what do we have here? GitHub, Clang build Linux. Let's see what's going on here. Maybe it didn't detect LLVM object copy. Maybe I just didn't realize that previously it was automatically disabled. Uncompressed file with setlib, set data error. What the heck? Produces crop debug string for emulation. Okay, that's not really sure what's here with setlib, but otherwise OpenSUSE default, yada yada, whatever, run. Memcat driver error. Yeah, 30 years later, see, so complex that stuff fails. Kernel checks support before using it. Recently I've seen build log with config x86 enabled, but no command running. Command manually seems LD is seg faulting. It's not seg faulting. Okay, maybe previously it was, I mean it might be something like previously LD was seg faulting or behaving otherwise difficulty. Maybe it's partially fixed, now it's enabled. This does not match what I remember having found previously. Yeah. C is difficult. Backlist resolved, x32. So what do we do with that? I mean, we could dynamically, so I actually started with, I didn't want to disable x32. I mean, how can we, do I still have an old build? I might run a kernel being built with that. Let's Clang, yeah, Clang LLD, yes. The question then is, do I have a x32? How would we? We could run, do I have anywhere a? I probably don't have a x32 test. I mean, I could. The question is that ABI enabled? The question is, can you somewhere? How did I install it? Do I have the kconfig here? Which do I even run? Kconfig 6412 maybe, x30. But it might have been enabled. If that is the, is this a Clang LTO? It's a Clang LTO version. So I don't know what's so fuzzle about it. It looks like previously it did build. And the question is, does it work? But it did build. Differential. Let's see, what do we even have here? So ELF, GNU property. What's going on here? Summary. N-type, node, encoded, program properly if pointer data size is invalid, LLD may crash. This patch adds new error checks, call supports and some test for invalid. So, I mean, our problem is that it's not crashing our. The question is a little bit, was it please use GitHub pull course new patches? 2022, thank you very much. Isn't it amazing when you don't find stuff you are searching for? Maybe the best thing to get here any further is to actually build a current production LLVM Clang version 16 and compare the files generated there. It of course takes a while. The problem is here in this cleaner tree. I guess I can revert the package developer. By the way, there was one more thing. So probably, do I have any configs here? Copy the whole config of T2, that is x6464. And compare what the state of those files is there, just to get an overview, even how that worked. Not to step around here in the dark. There was one other issue, which is somewhat related to the new... right, I remember. Another slightly related issue, so that probably builds some 30 minutes to get some, also theoretically, you know what, -rm, -rf, download. I guess I had the symlink from there to here. Not have all the stuff downloaded, I guess. The other thing is, of course, this broke. Of course, 2023 new LLVM Clang versions. Of course, it breaks. This broke this VASI stuff, this Webassembly. There's also complexity, right? Nowadays, I may sound like an old man yelling at gray clouds and having a broken record. However, nowadays recurring theme, previously you only need GCC, right? Now you also need, like, well, GCC and bin utils. Now you also need LVM Clang for your architecture, Rust. I surely have forgotten something, if not soon Zig and whatnot, and also the WebAssembly stuff, right? So you don't only need LVM Clang once, but twice also for the WebAssembly stuff, for this Firefox sandboxing technology stuff, right? RT or RL sandboxing or whatnot. So there's also failed with very stupid stuff. I also have no idea like how this constantly can happen, right? Why, I mean, I understand complexity, but with thousands of people contributing to LVM Clang, including Red Hat and SUSE and all the other millions of $1 million RPM forks, why is this not continuously tested, like continuous integration tested, especially in the context of Firefox and like this heavily financed Mozilla and Linux Foundation? Like, why do we need to sit here and analyze the stuff and begging for your patronage and super things and shares and likes? Because if this would be my project, like if LVM Clang would be my project, like I would have some continuous integration testing for this. Of course not for everything like Itanium and Spark, but I mean I would, but at least for VASI, right? WebAssembly stuff like is used in Firefox logs. But leave in the comments below what's your take on this. Like, yeah, VASI lib cxx failed, because of course it did. That is why the log file is 0, because I manually stepped over that. Like, yeah, you want to finally release your Linux distribution, but like the Linux kernel doesn't build anymore, VASI WebAssembly stuff doesn't build anymore. It's not like we can wait even longer for other people to fix the stuff again. And VASI lib 6, and then like 2024 Firefox is still using old versions of WebAssembly because shit doesn't build. Build x86. It's like, yeah, one regression had 2 regressions. var adm log VASI error, and I had this already patched previously. This failed. Like, so this is already with one hack applied. What fails no further is systems unknown to CMake. Where is the actual error? Could not find requested file. Handle lib cxx. CMake future version update min version. What even freaking failed here? System is unknown to CMake. Create platform VASI to use the system. Please post your config. I mean, I remember seeing stuff like that here previously, so I'm not sure if that is the real error. But the recurring theme 2023, you can't even instantly see the bloody error. Like, we have 2 dozens of build systems, but like Make wasn't amazing, but now we have 2 dozens of build systems that all suck even more. Because in my opinion, if you have a bloody build system and it continues stuff, like something fails and it continues stuff and it outputs so much random bullshit that you don't even on a first glance see what even freaking failed now. Like, I don't know, is it looking for, I'm not even freaking sure what not freaking failed. VASI lib cxx. I mean, what we could do is maybe we could continue to run the VASI. You know what we? Okay, let's do two things. Let's first document what precisely failed here, because I have already some hotfix for hotfix atomics. Because of course I worked already some 3 days ago on this. So previously it failed with not finding bloody atomics, which, like, seriously, you had one job. And yeah, looking for atomic fetch 8 in atomic not found, like what the freaking heck. I understand where that's coming from, I just don't. So is all the bloody platform VASI stuff is also there. So I patched that away because YOLO. What was even, do they have atomic? Why is this now not, or maybe I patch it away. System anyone looking for clock get time in RT found? I don't even know is, okay, this is error, so maybe that is the error. Remove flags, 480? I can't even make this shit up, this is so stupid. Like, I have a microkernel to write, a val to save and stuff, and we debug here around in the 24's most sucking build system. And I'm really getting disappointed by this stuff, I have to tell you. Which is this even building? CXX apparently, because of course we have two different. Which file was it? Which line I mean? Line 480 of course. So why does setup, so it fails with remove freaking flags? Like what the heck? Maybe is there a chance we built with the wrong CMake? But like why and how? Like what have I done wrong to deserve this? What? I mean, yes, recurring theme, we get the shit for free, we get the sources for free, but it's like seriously. I mean, it is not impossible that maybe we need to update the CMake. No, but I have updated this. So this is LLVM CMake 1701. But like, why is this shit in there if it doesn't freaking work? Or do we need a, I mean, is there a new CMake version? I mean, let's patch that away and see if it then freaking builds. Remove flags, include CXX ABI. Remove, like why is it in here if it doesn't, like, you had one job. I have no idea what's going on with this nonsense. It's absolutely ridiculous. Now this of course doesn't. Unknown config define. I must overlook something obvious if this fails. I mean, maybe we do this CMake. Maybe that should come from this. Maybe they changed the way they distribute the CMake stuff. No, it's not in there. Like, what is freaking wrong with you? I wish I would make this up. The last argument is called remove flags. Flag util CMake. Which CMake do we run? We run a freshly built CMake. This is absolutely horrendous. Also some neighbor, probably some neighbor cooks here. So smelling with onion that I get hungry. I slightly wonder how neighbors can cook so intense that I smell it here in the office. But now I get angry. Should find this neighbor and convince him to cook for me. Efficient parallelism of feeding your starving open source neighbors. Yeah, I'm speechless. I am speechless. Config define 734. What are we overlooking that this doesn't work? So many versions. 27, or I don't know. Is there a new version even? Nah. So is that even stable, or is it some... Yeah, website so large. Most important, selling training to survive. Download somewhere else. Where is this stable? Latest release, say 27.6 apparently. Oh, 6, slightly newer. 3.27. Oh, what? I did Justin download it? Or maybe data just updated it? Ah, data just updated this. Ah, cool. Nothing like having AI code. So, just another phone call. People keep calling here. Not even on a Sunday, you have your piece to work. To catch up with free open source work. So yes, it's not, it was remove flex, right? It's not in here. Remove flex, so remove flex. Where is the freaking heck is this supposed to come from? But I would not be surprised if the LLVM Clang people released their... I mean, somehow they, despite having that on some news sites already, I mean, they don't list it prominently here, right? So, big news sites, it's released, and the product themselves, yeah, let's better not put it on the front side yet. Here's Clang Extra. Oh, no, not Clang Extra. What even is Clang Extra? I thought CMake Extra. What the heck is Clang Extra? New in some main features. Generate intros. Oh, what the heck is that even? Yeah, so the only constant is change and regressions. I can't anymore. This is a pure comedy. It's like the big mega corporations. I was sometimes joking. They don't want that we built it. Like only the big $1 million investors of RPM are allowed to build it. It's clearly not in there. Let's tar. This is, what is it? CMake. LVM CMake. Let's extract the 1603. So not in there. This is ridiculous. I mean LVM and Clang build, which 17. Maybe I shouldn't do this verbose. So I don't use it here. They don't use it here. Wow. You can't make so much nonsense up. Vazi, libc, it's ridiculous. It's do they really don't want us to freaking build it, do they? Wait, let's see. That is all in LVM project proper. It's by the way not my fault, this stuff doesn't load right. LVM, so that should be in libcxx. What did we try to build? libcxx. Let's check that one. Remove flex. Can we blame that? Blame. Oh, the freaking heck caused that. Hello? Fix handling 8 years ago. Wow, this was effing not touched for 8 freaking years? Wow. And this stuff was also not config define. We had config define. How did this previously build? And did I extract already the CMake? Or is this a CMake regression? The level of bullshit that I need to investigate is really absolutely outstanding. And then people wonder that my mood is at times not the best. It's also not freaking in here. What the heck is freaking going on here? CMake, it cannot be LVM. Did someone already freaking find out where the shit is coming from? This is absolutely horrendously outrageous. How did this freaking previously build? Let's maybe do one thing. It's like also like investigating this some 10 minutes, like where the freaking heck is this stuff coming from? Or is this case insensitive in some way, shape, or CMake? No. Like what the heck? I have no idea what's going on. But let's revert this Vazi stuff. By the way, I just recently, because they constantly keep changing their mono-repository and CMake nonsense, I just had the last time with version 16 spent probably an hour or two quirking this Vazi shit to build, and now it's broken again. Like basically, I really have no respect for big mega projects that break their own shit with every freaking major release. Let's see if that builds. I've no idea if that's supposed to build or out of spec or might build when we are lucky. Let's see if that builds with the last Vazi stuff of libcxx. Probably should build this verbose. It runs surprisingly long. This freaking build. So this LLVM Clang, so that is with the same, with this LLVM Clang 17. I mean, of course I could diff then this. I mean, I obviously have zero idea where this remove flex stuff is coming from. I mean, maybe it's generated some, but no, it works with the same CMake and like this. Like the thing is, after 25 years building a Linux distribution in the industry, doing this professionally and everything, I really, I mean, I'm getting, I mean, beside burnt out, depressive, disappointed. It's like in this cluster of feelings and state of mind and whatnot. It's like due, and this is why we can't have nice things, right? That's broken, that regression, this doesn't compute, and this between segmentation fault and other undefined behavior. Thank you very much. I mean, we could quickly, what else do we need? Was it all? We could see if then with LLVM Clang otherwise were both Firefox builds. I probably also, I mean, I probably should quirk something, like maybe later tonight on the couch with some wine, or with this stuff increasingly whiskey, but not recommended, don't get alcoholic. I probably should quirk some stuff to build and then release a test ISO for other people to give this some good compute, like some good compilation and XFCE, GNOME, Firefox and whatnot use. Firefox the last time, what was it? Did it build in 10 minutes now? Actually, the question would be, how does a LLVM Clang 17 Linux kernel work on a perform? Like how would this perform? So that starts to compile. So that's the latest of everything. The question is also, do we have a new Rust version to break even more? Like, hey, shit is broken. Let's mix in the new Rust version, because you can never have your stuff too broken. Yes, a new Rust version to break some shit. Of course, we have to update this. So, updates. Nothing like more broken stuff. So right, data did this already, good. Then data did CMake. Let's ourselves regress some more. What do they even have? Finally, revert codegen changes. What? Partially revert codegen, improving codegen? Resolve some eyes in the compiler. So like, yeah, Rust safe, or like memory safety and stuff. Hey, resolve some internal compiler errors in our memory safe compiler and stuff. Yay! Oh, fix more regressions in compile time. In compile times? What does it mean? Shit is getting slower. Rust C was not slow enough. Let's checking if local is freeze. What do they mean with that? Fix regression in compile times? What do they mean with times? Does it mean compile times? How are compilation times on latest 90s for you compared to precisely PR artifacts? Fixing good backport, some simple. Okay, they really mean compile times. Okay, I probably have some more investigation to finish later tonight. Probably we are already easily an hour in. It's like, yay! People in their spare time, in their in-between time, keeping open source built with your patronage. YouTube, super, thanks, and share, like, and subscribe. Ian Fields, for me, can't tolerate more than a couple of hours a day now, and I'm not working on a little project. Can't progress more than a small pace. Yeah, and I mean, I wish, I would like to write a microkernel, right? For the one regret, like some other YouTuber says, you only regret, I probably should memorize that from Colin. You only regret what you don't do, also. You don't regret what you do, you regret what you didn't do, also. Which for me is, I was so into, I did already L4 stuff in 2005 and stuff. I was, and like 2000, like 15 years ago, I was like, dude, this is not stable and secure enough and whatnot, Linux kernel and so on. And my thinking is stuff like the state, I mean, not only the state of regular things like Python, Rust, LLVM Clang, GCC, and Linux kernel could be so much better if we would not ever change stuff and like more focus on performance, security, and features, and like constantly refactor stuff for the sake of refactoring. But even in the kernel, right? Like all research from the 80s and 90s, like monolithic kernels are not the most secure. And I mean, yes, performance, but I mean, performance could probably even be, given that stuff is so bloated that many things are like, what is the single address space monolithic Linux kernel performance when your compiler became anyway twice as slow over the last decade? So much to performance, right? Or like we now have Rust compilers that most compiler engineers joke about how slow it is, right? So it's like, I understand memory safety and whatnot, but yet Rust is simply slow. It is what it is. Like, yeah. And so instead of people having time to invent the next big things, we sit here and debug why LVM, why the Linux kernel doesn't build with LVM anymore, why, yes, in exotic configuration things, but nonetheless, why the CMake stuff doesn't even find its make files. Actually, I believe I diffed, like, let's quickly one last thing and then I really need to go home. Let's diff. That is, what is the name? Does it start with... Oh, so by the way, we probably could rebuild Rust. Let's x86 Rust and cargo and build it. Do they also have a new cargo version? 173.1 is still the latest. Good. What else did I want? All right, I wanted to diff. Is the download name probably lib standards libcxx? Yeah. Did I? Yeah, I actually. Okay, I probably diffed this already when I checked for the atomics. So I extracted it already the other day, as I said. So 16. Oops. 06. And I believe I probably was shocked how many changes this. Yeah, I was shocked. It's nothing like some small little CXX library and you have over 4,000 files changed. I mean, how can this be 150,000 in just a tiny little C++ CXX library? Absolutely shocked. How should we even... here. This is maybe why this stuff doesn't work. Here's... So they changed this from including current source tier CMake modules to runtime CMake modules. Maybe this is why this shit simply doesn't freaking build TM. probably I need to use this for... Man, what is freaking wrong with all those people? It's like... But, I mean, did the CMake shit warn that it doesn't even find some stuff? Or... Oh no, wait, this is additionally. No, I take this back. This is additionally, not... So... Yeah, sorry. So it looks like they didn't even change this atomic add test, so it's not even like with all those changes, the stuff that didn't work is this like add atomic add, here's some. But apparently not in the CMake file, right? Let's only diff the CMake file. This line that failed is not even in there. Wait, did I even diff that? What did even? I'm not even sure what. I just scrolled. By how large are those diffs alone? 200. It doesn't even look like the largest, but so. Let's do something crazy. Let's. Wait. Webassembly XX17, or was it like that? Let's use the CMake from the previous version. Let's just for the excessive testing here. 1606, or what it was. and okay, fine, should. Yeah, there was more, but I mean, we're not loading that, but don't tell me that would work. You never know. Probably should diff those others. x86-64 to Webassembly libcxx. No, unknown CMake command remove flags. So, but there is obviously something, some CMake nonsense regression. I check it later. This is, yeah. That's it for this video. I need some rest. Don't forget to like, subscribe. Hope you learned something, and to see you next time.